Galileo Galilei had a keen interest in mathematics since his childhood. In 1589, in his series of essays, Galileo presented theories about falling objects using an inclined plane. In 1592, he was appointed a professor of mathematics at the University of Padua, where he continued his study of motion on inclined planes, and reasoned that objects move with a constant speed when no force acts on them. Let us take a look at an experiment performed by Galileo. He took a marble and released it from the top of an inclined plane. He observed that the velocity of the marble increased while rolling down. Again, he took the same marble and this time tried to make it climb up the inclined plane. This time, he observed that the velocity of the marble decreased as it went upwards. Galileo further argued that if two inclined planes of opposite slopes were kept beside each other, then a marble released from the top of the slope will roll down only to climb up to the same height of the opposite slope. If the angle of inclination of the right plane was decreased, then the marble will go a bit further to reach the same height from which it was released. If the slope is ultimately reduced to zero, then the marble will move forever to reach the height from where it was released. In this case, the unbalanced forces working on the marble is zero. Hence, we can say an unbalanced force is needed to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. Here, we have assumed that no external unbalanced force is present. However, in practice, the presence of unbalanced forces like frictional forces restrict the motion of the marble. Isaac Newton further studied Galileo's ideas and presented three fundamental laws of motion. These three laws are known as Newton's laws of motion. The first law of motion states that an object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied unbalanced force. This means an object will maintain its original state of rest or state of motion and will resist any kind of change. A football on the ground does not move unless the footballer kicks it, and a football going towards the goal will not stop unless the goalkeeper stops it. This tendency of objects to remain at rest or to keep moving with the same velocity is called inertia. That is why the first law of motion is also known as the law of inertia. Let us consider an example of a car. If it suddenly starts moving, your upper body tends to move backwards. This is due to the inertia of rest of our body, which opposes the motion and hence does not let our upper body move forward. But the lower body, which is in contact with the car, moves forward along with the car when the car starts. When the car takes a sharp turn, our bodies tend to move to the opposite side of the turn due to the inertia of motion. Also, when brakes are applied to stop the car, our bodies tend to move forward. This is due to the inertia of motion of our body, which opposes any change in the state of motion. That is why safety belts are worn to prevent accidents. Safety belts exert a force that opposes our forward motion and make it slower.